there's this question of whether dark matter is going to be found to be particulate. Is it an extension of gravity? What do you think it is? Where are you sitting on this right now?
Well, yeah, I mean, I like the elegance of modified gravity because it seems like if you look at the movement of our Milky Way galaxy and other galaxies, it seems too smooth, and things stay together. And I know, and I'm intrigued by that. But then there's a lot of evidence, like the bullet cluster. If you look at that, the bullet cluster shows, for example, it's an image of what looks like two separate. I should put that up somewhere, but I'm trying to recall it. But it just looks like the way the gravitational lensing occurs, that there's got to be some particles. The gravitational lensing is such that it can't really be explained by the masses of the galaxies that are in there.
Right.
But so there's got to be something outside of that. So something that we can't see. And that seems to point to, some kind of particle that we just can't detect. So I am open to either of those possibilities. It seems like the evidence points to certainly there being a particle of some sort.
Interesting.
But I like the idea. I like the elegance of modified gravity as well.
Yeah.
And I think Sabina is probably more of a modified gravity person, and Lawrence is definitely, he thinks it's some kind of particle.
Yeah. One thing Lawrence, I think, got a lot of attention by using, this idea of nothing to describe pre-Big Bang states, or what, this hypothesis of what a pre-Big Bang state would be. And I know Sabina disagrees with him on that, with this, labeling this with the label of nothing. What do you think about that? When you think about pre-Big Bang states, I know sometimes some people will say, well, state, what do you mean by state? What I mean by that is simply just, a state of potential, not necessarily bound to any kind of space, but just simply some kind of state, even a state absent of everything else, but there's a potential for something to happen. How do you think about that?
Well, first of all, anything that I say or anything anybody else says is pure speculation.
Sure.
Because we have really no idea. We have no theory even of what happened before the Big Bang. Now, if you look at Lorentz theory, the famous, I've even made a couple of videos on this, like how something can come from nothing. Right. Well, by nothing, it really doesn't mean nothing the way we understand it. There has to have been something. And that something to me is quantum gravity, quantum mechanics had to have existed. If you give me quantum mechanics, I can create a universe.
You can create a universe, yeah.
Out of nothing.
Stephen Wolfram said the same thing, by the way, when we were talking together, yeah.
So if quantum mechanics existed prior to the Big Bang, what Lawrence is talking about could be true. But did it exist before the Big Bang? I don't know. Nobody knows for sure. And we have no theory for this either.
Yeah, I mean, this is what I'm working on. I'm working on this state of potential theory, which basically I am positing that one thing we can be as close to certain as we could ever be about anything. I think that there at least had to be some kind of state in which something could happen, whether that's a god, whether that's a leprechaun with special powers, whether it's, the state of quantum mechanics. I think there must be a state for something to arise from, like that has, even if it's extremely rare that universes are born out of these states. I gotta believe, I'm almost certain that there must be a state of potential.
Yeah, and I think our viewpoint may be just anthropic. I mean, we feel like something has to have existed for the Big Bang to come into being. And this is the thing that is very difficult to understand, and for us to really, for anybody to really be comfortable with. For example, when I make these videos about inflation, I made 2 videos recently about inflation theory, how the universe expanded at a very high rate, 10 to the 78th power, at 10 to the negative 36 seconds, when the universe was a fraction of a second old.
And this is where dark energy comes in?
Well,
or is that...
dark energy is a little bit of a different phenomenon, but they may be related.
Okay.
It's possible that inflation and dark energy are related. Dark energy has to do with the way the universe is accelerating its expansion currently. But inflation occurred at a rate much faster than the current inflation, or the current expansion rate of the universe. It was much higher than that.
Oh, and we have to talk about expansion, by the way, now that you brought it up, because this is counterintuitive, right? People always ask the colloquial question of expansion. Well, what's the damn thing expanding into?
Exactly.
Well, that question is just not quite correct, is it?
Exactly. So this is what's very difficult to convey, and also to understand. It's very difficult to understand, and it's even more difficult to become comfortable with. That it isn't like a balloon, the big, and it's always portrayed as like a balloon, as like an explosion.
Yeah.
So we're trying to relate that to real world experiences. Whenever there's an explosion, whenever you blow up a balloon, there's an outside and an inside of the balloon, right? So it makes sense that people would say, well, what is outside the balloon?
Right. Yeah.
But really, when when I am showing a balloon, what we're really talking about is the 2D surface of the balloon.
Right.
The inside is not the universe that expanded.
The 2-dimensional flatness, right? The plane which we live on. Yeah. Okay.
So a better analogy that other physicists use is something like raisin bread. So you start with a small piece of dough with raisins in it, a bunch of raisins together, and then when you bake it, the whole thing expands, and all the raisins inside move apart from each other, and more bread is created in between the raisins. So that's a better analogy.
So it's like we're like living in a half-baked cosmos that's still, rising. Is there a limit to that? Will the raisin bread, just start like falling apart? Or, it seems like the properties we are dealing with in our universe, maybe it can have infinite expansion, but it seems like that might be difficult for life to exist if we get to a certain level of expansion, right?
Well, yeah, I mean, there doesn't seem to be a limit. There's nothing within physics that says that there's a limit to how big the universe can get. So, it certainly seems like the universe right now we don't have any theory to counter this expansion. There's nothing that prevents it, because dark energy has overtaken any gravitational pull of the matter that is inside our universe. So it seems like dark energy is going to dominate for the foreseeable future. And this is why I think the consensus opinion of how this universe will end is really something like a big freeze, where everything moves apart, so far apart that, for example, there would be no galaxies near the Milky Way. Everything will be, eventually, the Milky Way will converge with Andromeda Galaxy and some other galaxies that are around the Milky Way currently.
Right.
But beyond that, I think I don't know the exact numbers, but something like a few billion years from now, we won't be able to see any other galaxies. So the entire universe of people born, say, 10 billion years from now, if the Earth still exists, they will view the Milky Way as being the entirety of the universe. They won't be able to see anything beyond that.
Amazing. So this idea, and I believe it was Michio Kaku I was talking to about this, string theorist, of course, with this hypothesized 11-dimensional hyperspace, which is the thing that, outside of our universe, the kind of the state of potential, I guess I would call it. But okay, let's say it is expanding in this 11-dimensional hyperspace. Where do these ideas come from? Is there any foundation to them? Have you really examined this to see if there's anything of meat there outside of fancy mathematics, or what do you think?
I didn't hear your interview with Michio Kaku, but if he's talking about 11-dimensional space, then I know he's a string theorist, so probably what he's talking about is the 11 dimensions of string theory. So these 11 dimensions would be contained within our universe, would be composed of all these 11 dimensions. Now, the thing with string theory is this, that these 11 dimensions, now, where are these 11 dimensions? We can only experience 3 of them. And maybe you want to call time a 4th dimension, but where's everything else? Where's the 7 other dimensions?
Right.
So the hypothesis is that these other dimensions are so small that we can't view them. So they would be like, if you look at a string from very far away, it just looks like a 1-dimensional object. But if you come close to it, it's 3-dimensional because you can go around it and so forth.
Right. And our 4 dimensions being X, Y, Z time, right?
Correct.
Okay.
Correct.
Yeah.
So the other 7 dimensions would be somehow rolled into they'd be so small that we can't really view it. Now, the problem with string theory is that in order to get a clue as to whether these dimensions actually exist, we have to use very high energies in particle accelerators that would be the size of the universe. So we can't detect these We can't detect these.
That's a tall order.
Dimensions. Yeah, we can't detect these dimensions, and we probably will never be able to, unless there's some other technology that allows us to do it. Now, within the idea of string theory, these 11 dimensions have shapes, kind of like a Calabi-Yau manifold. It's a 3-dimensional representation of an 11-dimensional object. But these dimensions can have various different shapes, almost an infinite number, at least 10 to the 500 different shapes. And each of those shapes could represent a different universe. So that's where the multiverse theory from string theory comes from. So there's several types of multiverses. There's not just one type of multiverse. I made my most recent video was about
isn't 10 to the power of 500 more than the amount of particles we have in the universe?
Yes, it's much more. It's much more than that. I think
way more. Yeah.
I think the number of particles is something like 10 to the 200 something is the number of particles that we have. Well, it might even be it's an infinite number, basically.
Yeah. So if we have 10 to the power of 500 potential states within these manifolds, does that mean that there are things that aren't possible? Would you say?
I can't imagine. You mean like types of universes that aren't possible in 10 to the 500?
Yeah, because I mean, we are putting a limit on it when we say 10 to the 500, right? 10 to the 500 is just, I think it's a number inconceivably large.
It's just some huge number that somebody put to make it a finite number.
Yeah.
But it all depends on the nature of these dimensions and what kind of shapes they can take on. If it's a continuous type of surface, then potentially it could have an infinite amount of ways that it could be shaped, and the combinations of those shapes would be a very large number. And 10 to the 500 could be
not enough.
Could be low. It could be a lot more than that. So I can't imagine that if at least it could be a limit of my imagination, but I can't imagine a universe that wouldn't be covered under the number 10 to the 500.
Right.
You know what I mean?
Yeah. So
So anything can happen basically with string theory. And that's why many physicists, perhaps most physicists,
don't think it's a very good theory.
Yeah.
Yeah, I mean that's the impression.
But it is useful. I have to say that it's useful.
How is it useful?
The mathematics of string theory has been used, for insights that are very useful in physics. So it has advanced physics for sure. It's not a useless concept or theory, or the mathematics are quite useful. So
yeah,
I'll give you that. And I personally I'm not averse to it.
Right. So then we get to the unification problem. We have no particulate representation of gravity on the in the standard model. Do you think the graviton's out there, or do you think gravity is not quite a force in the way that we see the other forces?
Yeah, I don't see how it would not be a force. I think it is probably a force, and something like the graviton probably exists. That's my view. That's my personal view. Everybody might not agree with it. But here's the reason why I think that, because we have this tremendous theory, the best scientific theory that exists, which is quantum mechanics. Everything in quantum mechanics, we've got the three fundamental forces are very well defined and make all sorts of predictions. Electromagnetism, strong and weak force. Gravity is the outlier. Gravity doesn't fit into the model because we don't know how gravity works at a quantum scale. Why would the universe be discrete, quantum, in everything except this one area?
Yeah.
So I think it's a limitation of our knowledge of things that we haven't discovered that is keeping us from really unifying everything. It's probably a very complex thing. Otherwise, we would have unified it by now. I mean, some of the best physicists in the world are working on this, and even Einstein himself was working on it and couldn't quite get it.
Maybe maybe we don't have the strong enough instruments. Maybe the particle is so small. Like, that's just me, like, armchair dude saying, like, is it too small? Like, is it too weak? Are we not going when we ram particle accelerators together? Is it just the chances of creating some kind of anomaly that has to do with the graviton is just like impossibly rare?
I think that's part of the issue. Yes, it probably is it's a massless particle I mean, most likely, I can't see it having any mass. A very small particle, but the very simplistic way to look at it is this: why haven't we discovered the graviton?
Yeah.
Why is it that we haven't been able to unify all these four forces? Well, the problem is that when you get to the quantum scale, the other forces like electromagnetism, strong and weak force, these are all measurable. They have effects, and we can make measurements that tell us that these things really do exist. But gravity is so weak compared to all the other forces that it is completely overwhelmed by the effects of the other forces. So it has a very small effect, and that is just not something that we can currently measure. Now, the singularity is where it all comes together. So the singularity is the hypothetical object inside a black hole that, according to our equations, and it's probably wrong, is an object with infinite mass density.
Right.
So something that has a lot of mass, but no volume. If you have zero volume with any kind of mass, if anything weighs 1 microgram with zero volume, that's infinite mass density.
So you said probably wrong, likely because of the infinite answer, right?
Yes.
Infinite mass density. Why is that? Why do we always think that infinity is wrong? in
Well,
physics,
well, not all infinities are wrong.
Okay.
For example, the gravitational force the gravitational force has an infinite reach. So your body right now has some effect on the sun.
Right.
Your mass has some effect on the sun, just like the sun has some
Probably
effect
more
on
than
your
10 to the 500.
Right, right. So it has infinite reach. Our Earth will affect everything in the universe to some degree. It has infinite reach. So that kind of infinity it makes sense. I mean, it is not, but we're talking about an object which has infinite mass density. And we're talking about a theory that everybody knows is incomplete.
Yeah.
All right. So the theory of gravity, Einstein's general relativity, is incomplete. Why is it incomplete? Because it doesn't tell us what happens at an infinitesimally small scale, quantum scale. It doesn't tell us that. We run into infinities. We run into something called a singularity. So I think it's a limitation of the equations rather than reality. It's probably not, a singularity is probably not real.
Right.
Probably doesn't exist. Something else is going on. We just don't understand.
It's useful as a hypothetical concept for now, it sounds like.
Sure. Yeah.
Oh, okay.
I mean, we know a lot about the inside of what it's like probably inside a black hole.
Mm.
But when you get to the singularity, which is supposedly at the center, and in reality, it's not going to be at the center. It's going to be everywhere. If you were inside the black hole, the time and space basically interchange, and
right.
You would see the singularity everywhere if you could actually see. You probably couldn't see anything inside. I made a video about this as well,
as demonstrated in the hit film Interstellar.
Oh, right, yeah. The bookshelf, yeah. You find your bookshelf.
Exactly. This makes me think of Hawking radiation.
Oh,
can you talk about that a little bit? Why is it a meaningful concept? Do you understand it? How can I better understand it?
Hawking radiation. Well,
it escapes. Does it not escape a black hole? Like the only thing that we have hypothesized to be able to escape the black hole? That sounds fascinating to me.
Yeah, I mean, so the escape is, I've made a couple of videos about this. It's an interesting thing. So the idea is, okay, so I'm going to really simplify it. So basically what's happening is this. At the boundary of a black hole, so nothing can go inside a black hole from our perspective, right? Because time, essentially at the surface of a black hole, stops from our perspective, looking from far away.
Yeah.
So then so like, how does something escape the black hole? So what's happening is, so Hawking theorized something like this, where in empty space, you have particle-antiparticle pairs.
Yeah.
All right, everywhere. That's happening right now. Inside our bodies, around us, all over the place. Particle and antiparticles are coming out of the vacuum of space, annihilating each other and going back.
Yeah.
And this happens so fast that it can't be measured. But there's evidence that it exists for things, things like the Casimir effect verify that this exists. So Hawking theorized that at the very edge of these black holes, you have particle-antiparticle pairs that are coming in and out of existence. And once in a while, what happens is a particle forms at the boundary. One particle stays inside and another particle comes out.
Oh, okay. So there's the radiation.
Right. So the idea would be that the one particle gets captured by the gravitational pull of the,
that makes sense,
and another particle on the boundary leaves. So, but this is such a small, the radiation is so small that we can't really detect it, because the radiation of the cosmic microwave background is much stronger than the radiation from these black holes. And as the equation show that as the black hole gets smaller and smaller, the faster and more radiation that comes out. So the only way we could detect it is if the black hole was a tiny little black hole, but it would, so much radiation would come out that it would last for only fractions of a second. But the black holes that we can detect now, like the black hole at the center of our Milky Way galaxy, the radiation would be so low that we can't really detect it against the background of the microwave.
Right. That's fascinating to me, and this comes from, our theories of black holes and how we expect them to function, and then from that you can extrapolate a new equation of how particles are going to function at the very small scale because of what a black hole is doing, basically, right? Because we haven't sent instruments in to measure these effects.
Yeah, I didn't understand the question. Say that again.
Okay. Yeah, I mean, how would Hawking go about discovering this? That's the.
Mm-hmm.
Is he basing this on like the way we would expect particles to interact with the black hole at that very small level?
Yes.
Okay.
So just like any theory, he started with a guess. All theories ultimately start with a guess, and then you use the equations of quantum mechanics to come up with to support this guess, this hypothesis, and then you try to find evidence that your equations are indeed telling you the truth. So Hawking radiation, I mean, most physicists agree that it probably does exist.
Right.
Whether there's been any detection of it, or I don't believe there's been any direct detection of it.
Right.
But most physicists think the equations seem to make sense. I mean, it's mathematically correct. So
interesting. Something that comes to mind when we talk about Hawking, I know in one of his final messages that he left for humanity was that he spoke of the fragility of Earth and how that he thought that humanity really needs to find a way to exit within the next 1,000 years due to the fragility of this rock we sit on. Now that can mean a couple things. It could mean like, impact from asteroid, probably our biggest threat. Outside
you think so?
I want to get your take on this as well. As an engineer, is there any threat to humanity that we cannot engineer our way out of?
Yes. Oh, definitely. There are threats. Unlikely though, very low probability. For example, if something called a hypernova, this is not like a supernova. A hypernova is many magnitudes larger than that. If a hypernova was to occur within 600 light years of Earth,
you get a pretty big suntan.
It would be, yeah, exactly. It would burn the entire planet. All life would cease to exist.
Yeah.
The problem is that we would not see it coming because it would come at the speed of light.
Damn.
So if it came at the speed of light, okay, I guess why worry about it? You're going to be fried and you'll never know that it came.
Yeah.
But anyway, it's so far nobody has discovered a potential hypernova within 600 light years of Earth.
Here's a weird
question. That's the good news.
Now that you mentioned that, maybe that's what happened to the Martians. And we see this this desert-like incineration body that we see now, but of course we have no evidence of that. But maybe do you think that is something we might come to find, that a what did you call it?
Hypernova.
Might have, this could be the reason why intelligent species go extinct, right? Maybe.
Well, I mean, sure. I mean, it could be one possibility, but there's a myriad of ways.
Right.
there's a myriad of ways that life could end on Earth. I mean, we've had major extinction events on Earth in our own history. I mean, we're here because the dinosaurs died.
Yeah.
So there's some good that can come out of extinctions, right?
Yeah.
We wouldn't be here if the asteroid didn't destroy the dinosaurs 65 million years ago.
I hear a lot of people take the climate change issue to kind of what I think is an extreme. I see, and I'd like to again hear your perspective as an engineer. I see that all of these supposed issues that can come from climate change that could potentially harm humanity if we don't do something about it. I see ways that we can engineer our way around those things. Do you agree with that? Or do you think there's anything within climate change predictions that would be of great difficulty to us to overcome from an engineering perspective, like rising sea levels, needing to relocate, maybe building giant biodomes over cities or even countries, is there anything humanity cannot overcome with regards to climate change?
I think there's a point of no return when it comes to climate change. Are we at that point of no return? I don't think we are. I think we could still engineer our way out of it. But the problem is that, first of all, something needs to be done. Something a lot more than what we are currently doing, in my view. A big chunk of our population doesn't even think that it exists and that it's not a problem.
Right.
That's a problem, the non-recognition of it. That's why I think this is all part of science education. I think that the more people like Sabina and other YouTubers can help educate the general public on the basic sciences, including climate science, I think that's good. That's good for Earth. That's good for us.
Right.
Are we at the point? I mean, some people say that we're beyond. I don't think we are. I think, we could take drastic steps now to reverse
I think
it.
David Suzuki's been saying that for 40 years.
Has he? Yeah.
Well, a few of these guys that I would say are more on the, supreme alarmist side of this. But yeah.
Yeah. I mean, I think supreme alarmist is also counterproductive because, I think if you raise the alarm all the time and think that, well, there's nothing you can do, we're already beyond the edge.
Right.
Then it's like, okay, we can't do anything. Might as well just live it up.
Right.
Drive your big cars, fly wherever you want. So I don't think that that's productive either. I don't think that we're beyond the point of no return, but I think some drastic steps need to be taken. And the problem is, we have to do it in lockstep with the other nations of the world, because it's like one boat, right? We're on the same boat. China is on the other side, and everybody has a gun.
Yeah.
You know what I mean? And they're shooting at the bottom of the boat, and China is shooting over there, and we say, okay, well, they're sinking over there. I'm going to shoot here too, because they're doing it over there. Well, then you're going to sink faster together. It's all one. We're in one ship.
Yeah.
So it's not like somebody can cheat over here and it doesn't affect us. We all have to do it in lockstep. I mean, we walked out of the international climate agreements,
right?
And we're one of the biggest polluters in the world.
Mm-hmm.
So I don't think that was a smart idea.
Right. That was brought to you by the Donald.
You know who? Right.
So when I watch your channel, when I watch you speak here today, you seem to have a deep love for teaching and education. When did that start? Were you always into storytelling and sharing ideas? Or tell me a little bit about the origins of Arvin Ash.
I really didn't think anything of it. I do have a lot of stories to tell. I mean, not all science related, obviously.
Yeah.
But when I got the teaching position in college, I was teaching actually Mechanical Engineering 101 was one of the classes I taught, and we use a CAD program where you basically you draw a shape on a computer, and you try to look at all the forces that are on various points in it.
Cool.
So like people were having trouble. I forget what kind of shape we were using. It was kind of an odd shaped shape. And I said, imagine this like Scooby-Doo going through a door, you know, and you see his arm kind of like this,
Yeah.
you know, through the door.
Yeah.
He's going to. So imagine pushing this shape through a door like that. What would it look like? Draw that on your screen. So people have started to draw that. And I remember my advising professor was in the room, and he said, you know, that's pretty good. That's pretty good, you know. Yeah, I think you have a gift.
Yeah.
So anyway, he encouraged me. And then I started teaching more classes as the opportunity arose. I got paid for it. So it paid for my graduate degree when I was doing it. So, you know, and I liked it. And
cool.
You know,
and how did the YouTube endeavor start? Was that just a natural step for you to want to make videos?
Well, so that's a story. I mean, have we got time for this?
Oh yeah, hell
tell
yeah.
you a story?
We got 20 minutes left on the podcast here, maybe
so,
a bit more. Yeah.
YouTube was I had no intention of starting a YouTube channel. My YouTube channel started with a tragedy. I was on vacation on a Caribbean island with my family, with my parents, my kids, and my brother. And we were staying in a villa, and my brother went out for snorkeling, and he got caught in a riptide and died. I could see him from the villa because I was at on the beachfront. I could see him in trouble. I ran down to the beach, tried to get him help, but it's the Caribbean. Nobody thinks anything's going on. By the time they got to him, he was pretty much gone. They brought him to shore. I did mouth to mouth, did CPR on him. Myself, my own brother,
Yeah.
There were people on the beach that helped. We did CPR on him for like 2 hours because it took an hour for the ambulance to arrive. It's the Caribbean. It's not like the United States or Canada. So anyway, he died on that trip. And the saddest part of it was that, for me, was that like a couple of days prior to that, my brother and I got into an argument about something stupid. I don't even remember what it was about. And, we were kind of avoiding each other. So the time that he died, the last time I saw him was like a couple hours before that, and he offered me a piece of pizza and I refused it. But I sort of had an existential crisis after this because I wish I could relive it and it I wouldn't be so petty and I wish I got a chance to tell him I loved him, but
man, that's tough.
Anyway, I had an existential crisis after this because I thought, he had his whole life to live, and it just ended in a flash. I mean, that could have been me. I could have gotten caught in a riptide. What does it all mean? I mean, for him, it seemed like it was just meaningless. He hadn't fulfilled any purpose in life. So anyway, now the funny thing is that my brother and I, when he was alive, we always talked about these kinds of things. We talked about, he was a big Star Trek fan. We talked about, the meaning of life, what aliens would be like if they visited us, black holes. I mean, all the stuff that's in my videos, he and I used to talk about. So as kind of I went through this mourning period, and I just said, you know what? I'm just going to put this stuff out there. The stuff that we talked about, I'm going to pretend like I'm talking to him about it or explaining, because he used to look up to me and I used to explain stuff to him. And, he was, are there, like he was into Star Trek, and he was into stuff like, there could be aliens in Area 54 in New Mexico and stuff like that. And I used to say, no, it's not. So anyway, I just started putting stuff out there based on some of the conversations that he and I had and some of the arguments that he had. And it was a way for me to, I don't know, I guess find purpose in his life. Yeah. And I actually didn't care. I didn't care about my job. I didn't care about anything. And I thought, people don't really care about this either. So actually, when I started the channel, I called it something like, "Who gives a bleep?"
Right.
I think I called it "Who gives a bleep?"
Yeah.
Because I didn't give a bleep, and
Yeah.
I didn't think anybody else would give a bleep.
Yeah.
But I wanted to make good videos, so I tried to make a good quality video out of it. But I had no expectation that anybody would watch it.
Yeah.
But over time, people started to watch it, and I started to make more and more on more subjects that he and I talked about, and it kind of grew from there. But yeah, if it wasn't for that, I wouldn't have started this channel.
Yeah,
it was just my own inner existential crisis of, what does life mean? Why am I doing this? Let's just put it out there. And maybe we get a few converts to science. And, maybe they become the scientists that discover the next, they discover the graviton, or,
this is
the next Einstein.
Yeah, I mean, what a noble pursuit, and what a way to honor your brother.
Exactly.
And what a tragedy. I mean, I'm so sorry you went through that, and
appreciate it. Thank you.
It's it reminds me, when you're talking about that, about having a brother to share that with. It reminds me of my relationship with my younger brother, where we we debate, we talk. Sometimes our conversations on the phone end in kind of yelling matches, because we're so passionate about like what we're debating, and and of course, after any of those questions, that could be the last time me and my brother speak with each other, right? And
exactly.
And it's hard to live, it's hard to live that way. It's hard to live in these relationships in a way that we kind of say goodbye, or we say I love you in a way that we would be satisfied if that was the last moment we had with our sibling, or with our mothers, or with our fathers. How do we live that way, so that when tragedy does strike, it's not as much of a blow? You go through that, but it's just like, what else can we do? Because we're like, what can we do?
Yeah.
I mean,
that's a good question. Tomorrow is not guaranteed for anybody.
Yeah.
One of my best friends said something the other day that I thought was profound. Really made me think. And he said, think about everything that you do, anything that you do right now, anybody that you see. There will be a last time that you do that. No matter what it is that you do, person that you see, there'll be a last time. But you don't know what that time is going to be. Mm-hmm. It's so true, right?
Yeah.
I mean, you're walking right now. We're on this call. There will be a last time that you do this.
Yeah.
You won't know when that is.
There'll be your last slice of pizza. There'll be your last kiss. There'll be your last time watching your favorite film, your last time listening to your favorite Elton John album.
Yes.
It's and this does bring us to like this question of meaning. Like, what does it all mean to the individual? Is there a meta meaning? Where do you land on that? How do you find meaning? Where do you get it from?
Well, so I don't think that there's a cosmic meaning.
Yeah.
I don't think that there's an innate meaning to life in general, but I think that there's certainly meaning that people bring to their lives in their own way. Some people find meaning in religion. Some people find just meaning in what they do. Right now I'm finding meaning in disseminating science information. And, when I read some of the comments about people who are inspired, I read comments at least once a day about someone who says, "Hey, I'm going to go into science, or I'm going to go into physics."
Yeah.
And you were part of the inspiration. That makes me feel good, that maybe I changed the world in a positive way. To me, that's meaningful. Maybe my life has, my pathetic life has some purpose. So, you're doing this, right? You're interviewing people. You're setting up these seminars, and that affects people. I think meaning for me and for most people is probably in helping others in some form or another. And I think you're doing that, by setting up these conferences and, providing some fulfillment of thirst for knowledge that people might have,
Mm-hmm. Yeah.
So that's my meaning, but everybody, in my view, has purpose and meaning in their own lives. Some people find purpose in like I said, in religion. Others, it's their kids.
Yeah.
So, but I don't think that there's a deeper cosmic meaning that
Right.
we all have.
Right. Do you have ways to express yourself artistically? Do you kind of do that through your videos? Are you a musician?
Oh,
Have you? Yeah.
yeah. I'm not like Sabina that sings.
Yeah.
No, no, I don't have any talent. I'm really talentless. I cannot sing to save my life. I have the worst. I'm tone deaf, I think, because I sound terrible. I sound good
we
in the
can
shower.
test it out right here.
Oh,
live
no,
on the
no,
air.
no. Yeah,
Give you a
no,
live
no.
lesson.
And lose half my audience. Yeah, I think that's what will happen. No, I don't really have much talent at all.
Well, I couldn't disagree with you more on that, because I think you have the best physics education channel going.
I appreciate.
And I do
It's
mean
not
that.
true, but I appreciate
Oh, I
thought.
do. I do think so.
But
I'm an evangelical Arvin Ash worshiper and follower, and I share your videos as quickly as they come out. So I'm a huge
nice
fan of your work.
I appreciate that. I mean, one of the things that I'm doing right now is, so I used to make about one video a week. Last year, that's what we were doing, and it was too much. I mean, I was driving my staff crazy. I was driving myself crazy. It's too much work.
Yeah.
So this year we're making 2 videos a month instead of one every 2 weeks we're putting out. And I'm trying to actually make them higher quality, more animations, better animations, taking more time to make it right, maybe make them a little deeper. So that's since January since February, I would say.
Yeah,
we're pursuing that.
I think the animation world, the video production world, has added so much to science education. Some people really do have to see these things. It's not enough to grab a book for some people and read it and be able to visualize these abstract concepts. These really in some senses counterintuitive things, like the Heisenberg uncertainty principle. It's like you can explain that to someone 1 billion times and they're like, what the hell are you talking about? And then you show them a simple visual or animation of the gas demonstration, right? Moving or the double slit experiment, of course, is one. I love that these animations are being created, and that they're being done artistically and in a bright, interesting way. I think anything we can do to better sell people on what is going on in reality, because I think science is the way that we try to understand objective reality, and I think the more we can do to attract people in that way, the better. And I try things as a producer of intellectual content and through my own philosophical pursuits by working with different artists who do different design concepts for live events and things like that, and maybe someone through that who's interested in the superhero fandom, or they're from the superhero fandom, maybe they will be turned on to an intellectual event that they normally wouldn't have been turned on to.
I mean, most people are visual learners, I feel, or at least highly influenced by something seeing visual. This is why, when I took, my first quantum mechanics class in college, there was no YouTube, I wish YouTube existed. So it's really great for students of quantum mechanics today to be able to visualize this thing. Quantum mechanics was rated at my school the most difficult class on campus. The most difficult class on campus. I'm the only person that I think that I knew of that actually enjoyed that class. But part of the reason nobody enjoyed that class is because it's very difficult to visualize. Very difficult to visualize quantum mechanics. Everything is in equations. And the professors did their best to draw things on the chalkboard to help us visualize those kinds of things, but it's nothing like 3D animations that we do or other YouTubers do today, or even 2D animations. If we had it back then, I think it could have really helped people in that class learn it better, be more interested, and maybe the class wouldn't have been so difficult.
Right.
So I think it's a huge thing, and that's, why make a YouTube video if you're not going to use visuals? If you're just going to talk there, it's just like taking a class. To me, that's a waste of time.
Right.
So that's why I try to use a lot of visuals. Everything that, I try not to be on screen for very long. There are other YouTubers that just stay on screen, and
Right.
I don't understand that, because it should be visual in my view.
Mm-hmm.
So that's why, we're trying to do more animations, better animations, to get the visual message out there, because I think that really helps.
Yeah, I mean, the fact that people can go online and get a pretty damn good education in physics is a beautiful thing, especially to autodidacts like myself who don't really learn in the traditional, school environments very well. You kind of have to be alone and kind of teaching yourself.
I think there are many of you. Which is good, because maybe you're learning or trying to learn some things that you otherwise wouldn't have even attempted.
Yeah. Yeah.
Right.
Totally. I wanted to finish off what I think is the most interesting question, unsolved mystery, and that is, consciousness, or maybe the artist formerly known as consciousness. What do you think? The engine behind minds really is?
Well, it's interesting. I interviewed Jim Al-Khalili like a month or two ago, and I have to agree with him. I don't think there's anything magical going on. So a lot of people, think that it's something magical, that consciousness, for example, arises from some central consciousness in the universe, and we're like radios that are tuned into it or something like that. I don't think anything like that is going on. I mean, all the evidence points to consciousness being formed inside our brain. There's no evidence to show that anybody without a brain has any consciousness, or anything without a brain has any consciousness. So I think that it's an emergent phenomenon based on the interconnections of neurons in our brain working together, and at some point, the self-awareness and what we consider consciousness comes out of there. How it happens, I don't know. No one knows really. Yeah. But this is not. I think that the problem is solvable. It's not like we're going to discover some supernatural thing that, we're not like radio. It's all up here. It's all happening here. Yeah. How it happens, I mean, the brain is largely a mystery.
Yeah.
I mean, when I went to medical school for 2 years, it was a total mystery, but we know a lot more now than we did back then. And, our knowledge will keep increasing about how the brain works. And someday we will know how consciousness arises. Does it arise in a particular part of the brain? I don't think so. I think it is a kind of an emergent phenomenon due to everything kind of working in sync together,
Now, and when I hear someone describe it the way you did, which I agree with, is this not just very, very complicated machine learning?
Well, so
because
you're asking
people
whether
always want to separate it and say, okay, machine learning isn't intelligence, but I mean, isn't of the most extreme advanced version of machine learning that we could ever conceptualize, isn't that going to appear as an intelligent AI?
I don't see why not. I think it could. I think robots, machines, if it's an emergent phenomenon due to the various interactions of our neurons in our brain, I don't see why the same kind of emergent phenomenon could not occur in a highly advanced computer. We're not anywhere close to it, mind you. I'm not saying that machines today are conscious, but I don't see why it could not happen in the future with very advanced interconnected circuits, perhaps using quantum computing, some kind of quantum computing bits inside brains. It doesn't even have to be a quantum computer. I think if a conventional computer, if it's powerful enough and interconnected enough, I don't see why it couldn't happen. I don't think there's anything special about biology that makes consciousness exclusive to biological creatures.
Right.
That's my view.